day 2, and just a reminder, we are recording.
Well, hi everybody. Let's get started here. We're a couple minutes past, and I'm sure we'll get more people joining, but thank you all for tuning in. Got a few less people now than yesterday, but I imagine that'll climb as we go. Let's see, I won't repeat what I had to say yesterday, but suffice it to say, for those of you who weren't able to join today, that it's pretty clear that Above is on a very strong track with lots of publications and lots of data sets published and archived for future use, and a lot of great science is happening. I think we've got, I guess we'll hear more about it tomorrow, but we've got a lot of really exciting synthesis activities coming together, which from my perspective is really important and nice, because it means that there's a whole lot of different projects that are coming together and leveraging their findings and the results and working together and sharing data sets, and that's the kind of interaction and collaboration that'll make all of this more than some of the parts, more than a bunch of individually funded proposals, which is really what we aspire to. So that's great. We had a lot of good presentations yesterday, and it was nice to see people put a lot of time into them, and they were very done. We also have, hopefully most of you have looked into the posters. We have a lot of really good posters, and some chat going on back and forth about those posters, so that's nice to see as well. I wasn't able to join Happy Hour yesterday because I'm in a different time zone, but hopefully that was fun too. So yeah, I think that's all the introductory comments I have for the beginning of day 2. Peter, did you have anything else you wanted to add before we kick off the presentations?
Yes, if you'll advance to the next slide, Leanne. I wanted to mention about the posters that in addition to the really cool songs and videos and things like that folks have put together that you'll see mentioned here, that 3 of the early career scientists, Lauren Thompson, Mackenzie Kuhn, and Lydia Kaushik, have put together for Thursday at 1 p.m. Eastern a poster session. I really appreciate their initiative, and didn't want anybody to think that I had come up with that idea. I'm really delighted, and we'll probably try to do something very similar for future meetings. So in any case, there isn't anything on the agenda quite yet, but you should expect to see email directions on how to join the poster sessions at 1 p.m. Thursday. And that's it, I think. Liz, take it away.
All right, great. Well, we're starting a little ahead here, so hopefully we can stick with this. I'm Liz Hoy, and I work in the Carbon Cycle and Ecosystems office, and work with Peter to help on Above. And I'm going to moderate this progress report session today. So we're going to start off with Natalie Bowman, and she's going to be talking about socio-ecological consequences of snow and ice skates. So go ahead and take it away, Natalie. Can't hear you quite yet, Natalie.
How about now?
Yep, we can hear you. And I don't know if you wanted to turn your... Yep, I see you now, too. Perfect.
Thanks. All right. Well, good afternoon, everybody. So today I'm going to tell you about our Phase 2 project titled Quantifying Sociological Consequences of Changing Snow and Ice Skates. So I'm leading this proposal, and I'm working with a fantastic group of PIs, Todd Brinkman, Glenn Lipton, Laura Crew, and Adele Reinking. And we're also working with a fleet of collaborators from various academic institutions, government agencies, and a couple of private companies as well. Oops, right, next slide. Right, yeah, I got those in perfectly the wrong order just to confuse everyone, so thanks, Leanne, for dealing with that. So you may recall from my last presentation at the last meeting that we have 4 objectives. I've highlighted, or bolded, sorry, the ones that we've made some progress on. So the red bolded ones are things we've done some work on, and then within those objectives we have some sub-objectives, and the ones that are ticked and bolded in dark blue are the ones that we've started to make some progress on already. So the other ones that are in the lighter blue color, I won't be touching on today. So the first objective has to do with, first of all, quantifying snow and ice skates, how they've changed in the past and present. I'll touch a little bit on that today. Our second objective is to take some of those snow and ice products and weave them into what the consequences are for natural resources and subsistence opportunities, and the specific sub-objective that we've been working on thus far is how that plays into the efficacy of moose surveying methods. And then the third objective is all to do with winter transportation networks and how those are changing. We have the objective associated with large-scale all-season road and winter road transportation networks, as well as smaller subsistence trail networks, but we've focused on the road ones to start with. And then our fourth objective has to do with carbon cycling and climate regulation. Next slide, please. So for the first objective, we have to quantify spatial and temporal dynamics of these snow and ice skates. And again, these are to support our second through fourth objectives. We're taking the data model fusion approach using Glenlis and snow model that takes in situ observations, remotely sensed observations, and numerical modeling to produce these cold season environmental variables. Next animation. And can produce cold season variables at various temporal resolutions, depending on what the specific study is, which one of those objectives we're working on. So from 3-hourly to daily temporal resolutions, temporal extent, depending on the specific question we're working on, can range from 1980 to 2100. Similarly, spatial resolution, depending on the application, 30 meters to 1 kilometer grids. And we're working all the way up to the above study domain, but we've zoomed in on specific areas with different combinations of spatial and temporal resolution, depending on the specific objectives. Okay, so next slide, please. So the status of objective 1, in other words, status of where we are with producing these cold season environmental variables. This is the table of all the different environmental variables that we have proposed to produce for this project. But as we have started, even just in these early stages, we're realizing that in fact what we need are some more. So there are other things that we are already developing that aren't on this list, and I'll show you a couple of them that we're realizing, oh wow, well what we really need is this, that, and some other things. But just to stick to this table, we've Glenn and Adele went ahead and color-coded just to show what we've done, what we're working on, and what we haven't started, or what's already publicly available, so things that we want to make change. So the green stuff, these are variables that have been developed and can be used in simulations. Yellow variables are things that are where development is underway. We have a few of these that are new that we didn't realize we needed, but I'll show you a couple of them at least later. And then the orange are variable development that hasn't started yet, and the gray are things that are publicly available. Next slide. Okay, so the first sub-objective is motivated by the fact that poor snow conditions significantly hinder Alaskan wildlife agencies from their ability to monitor moose populations. So next slide. These surveys are done aerially, And they're typically done during November and December, October and December, when leaves have fallen. Deciduous trees and shrubs have dropped their leaves, and you can see them easily from above. Next slide. And critical, also, as you see from these photographs, is that the ground is covered in snow. You can see that in the top, moving down towards the bottom, it's a whole hell of a lot easier to see snow from move from airplanes when there's snow on the ground, and increasingly difficult when there isn't. Next slide. Further constraining this, though, you've got to wait for fall snowfall to be adequate, snow cover to be adequate, but you're also constrained by time. There's only day length decreasing as you get deeper into winter, and so you're running up against shorter day lengths. Next slide. And on top of it, when you're doing these surveys, the surveyors need to identify male versus female moose so that they can decide on harvest quotas in terms of how many female versus male moose can be harvested. And the antlers drop typically in January, adding another element of constraint on when these surveys can be done. Next slide. So one of our objectives is to help land managers predict where and when and how they may alter their survey methods, given that snowfall, snow cover is pushing later and later into fall and becoming less easy for them to predict and go out and do their surveys. The coverage is not as ubiquitous and dependable as it used to be. So you may know that Alaska is divided up into different game management units, shown here. Next slide. For our initial analysis, we're focusing in on 2 game management units, 15 and 20. So we know from our ADF&G partners that between 88 and 2019, in GMU 15, these colors are messed up, which is the purple one down the south, 19 out of those 32 years, they were able to survey. The rest, they were not able to survey. There wasn't adequate snow coverage. GMU 20, this one is the bigger one in the south, 26, they were able to survey, and the remaining years they were not able to. These surveys were done October to December. Ardell ran snow model from October to December, daily resolution at 180-meter resolution. Next slide. So look at how that happened, what were the snow conditions like. She ran it and got a snow-covered fraction for this GMU for all those years, all those days. I'm just going to highlight Halloween in 1992 for GMU 15, so that one farther south. Next slide. That snow cover fraction is the snow depth. Next slide. This is a newer product based since the last snow accumulation, which is figured would be useful for the surveyors. Next slide. But then what we really discovered was more useful was the age of snow, or snow freshness. And the reason that this is important, next slide, is that newer snow tends to stick to the canopy more than older snow, which eventually falls off. So it's more of a measure of landscape whiteness, which we quickly realized is actually what they're after. So they really want that contrast between the dark moose and the white background. So canopy whiteness is something we're working towards. What are the different snow metrics that we can come up with that we can combine to give them a measure of canopy whiteness, to predict that for them over the GMU so they can make decisions on whether to go or not go to do their surveys at specific times and locations in various GMUs. Next slide. Here's an example of some early results from GMU 20, so that GMU that's farther to the north in the interior. This is from Todd Brinkman and Adele working together with our ADF&G partners. So this is some snow depth this time on this map, where the green is deeper snow, the red is shallower snow. The data we get from ADF&G is either go or don't go to do the survey. Next slide. On the left, you got the 2007 snow depth. On the right, 2008 snow depth. What you'll see, next slide, is that we have deeper snow in higher elevations in 2007, yes, but much of the DMU as a whole had very little. And so what happened is the surveyors told us we didn't go in 2007, but we did go in 2008. So because half of the DMU had no snow cover on it, it wasn't worth going out and doing a survey because we knew we wouldn't be able to effectively survey the moose and get numbers that we could count on for determining harvest numbers. Okay, so this is the type of stuff we're doing for there. Next slide. Expected products for this are estimates of snow variable thresholds required to conduct the moose surveys and statewide models and projections of survey probability based on snow conditions. Next slide. For our road network goals, this is motivated by the fact that dynamic snow and ice conditions on winter roads affect the seasonality and duration and safety of travel along the road. So the Yukon and Alaska both have quite a comprehensive, given how sparse it is. There's still quite a network of roads up there that are open all year round. So we're focused on the winter season when they're covered in snow and ice. Next slide. How can we help Department of Transportation in both sides of the border predict the safety and the road opening and closings will be at any given time and location? So here, we're just about to run some simulations. Adele's about to do this at 500-meter resolution. We're doing it for the last 30 years. But here I'm just showing you an example. We're doing this, along the Dalton and the Dempster. Here's just a small part of the Dalton Highway from milepost 356 to 414, just for 1 year, 2013 to 2014, where you see this text file here is just showing all the accident reports, openings and closings. And it tells you what the road conditions were like, what the specific event was that caused the vehicle accident, what kind of snow, was it snow drifting, was it a flooding event, an icing event, what happened, so that we can relate it then to our model of blowing snow layers, drifted snow layers, icing events, melting, flood events. Next slide. That's it. Got any questions? Thank you.
Natalie, is that a road kit?
This is Lee viewing young Idol and Kevin Griffin on the Dempster. This is early March, and we were driving along, and off in the distance, Lee spotted this caribou on its back with its legs up, and we marched out to it, and lo and behold, there it was. I think it just fell over and died.
Yeah. It probably would have been safe to try and take home.
Liz, we can't hear you.
Oh, thanks. Well, thank you for noticing that. So we'll move right into Min Ten's talk about the quantifying socioeconomic impacts of changing Arctic ecosystems using above data sets in an integrated human Earth system modeling and data assimilation framework. And just a reminder to everyone, if you do have a question, to please post it in the Q&A system, and we've chatted that link out to everyone in the chat box, so remember to stick your questions in there. Thanks.
Great. Can you hear me okay now?
Yep, we can hear you.
Great. Good afternoon, everybody. So our project is the new above project, focusing on the quantification of socioeconomic impacts of the Arctic ecosystem changes. So, I'm serving the team PI, and the work has been greatly contributed from our co-investigators, Drs. Ben Lamberty and Corinne Harton, and postdocs Dr. Han Chu and Yelu Ding and Jin Liao. Next slide, please. The core tool used in this project is the Global Change Assessment Model, or GCAM, which is an integrated human Earth system model, or commonly known as a integrated assessment model. GCAM is one of the representative models that facilitate understanding of how human actions in energy, land, and economic systems interact with one another and affect or affected by the global environment in the background of global change. For example, GCAM has been used for producing global change scenarios such as the representative concentration pathways, RCPs, and shared socio-economic pathways, SFPs, that the global climate modeling community might be most familiar with. And GCAM has an embedded single climate model named the Hector, which you can see that in the figure on the left-hand side. Hector simulates global climate in response to greenhouse gas emissions. The problem is that the Hector was developed with oversimplified ecosystem processes. So the overall objective of this project is to link the models that represent the most completed ecosystem processes, for example, the community land model, and use the data collected in the above campaign to improve CLM and link the CLM to Hector and GCAM to examine how the ecosystem changes would affect the world's energy, land, and economic systems, and what the value of this as in reducing the uncertainty of these effects and the dollars we're going to spend for mitigating the climate change. So in the first year, we have successfully set up the CLM Hector GCAM workflow with tremendous efforts on solving issues for coupling these models. So far, we have completed a few modeling experiments in order to examine how the future land and energy use would respond if we use the quantification of wetland methane emissions from CLM rather than the default values of Hector, and what the role of the contribution from the highlighted region. The figure on the right-hand side shows the very top level results from the modeling experiments under two scenarios, SS1 RCP 2.6 and SS2 RCP 4.5, which are defined with high and medium mitigation efforts. For example, under SSP1 RCP 2.6 scenario, if we use the default wetland methane emission in Hector, we will expect 46% clean energy to be used worldwide in 2050. Those clean energy includes bioenergy, solar energy, wind energy, nuclear energy, etc. However, because CLM projected higher methane emissions, so there will be more pressure for us to achieve the radiative forcing 2.6 watts per meter square target. So we will expect higher clean energy use at 52%. An interesting result we found is that if you assume methane emissions in northern high latitudes keep constant at the same level in current years, we will expect even more clean energy use because CLM projects declining methane emissions in northern high latitudes in the 21st century. That's totally out of our expectation. So similar results can be found for SSD2 RCP 4.5. I think overall the take-home message here is that CLM Hector GCAM workflow has successfully linked the ecosystem and social ecosystem dynamics, but CLM might underestimate methane emissions in northern high latitudes, which is out of our expectation. The details are in the poster led by Dr. Hanchu if you're interested in going there. Next slide, please. Another interesting study that I want to show here is that we developed and implemented an algorithm in CLM5 to better simulate the soil-induced chlorophyll fluorescence. The study actually originates when we were thinking about assimilating SIF into CLM, but we found that there was a big gap between CLM simulated SIF and the satellite observed SIF data. In brief, the existing CLM safe implementation by Lee et al. 2015 it's a quite very solid work, but it uses an empirical parameter K to directly convert the subsystem SIF to the top of campus SIF. And K is modeled as an empirical linear function of the maximum substance capacity known as Wikmax 25, the parameter in CLM. But I think more importantly, this approach neglects the radiative transfer process or the state ratio of SIF and the BRDF effect of SIF. So here we developed an algorithm to model this process in a more mechanistic way and use a practical approach of estimating the SIF escape ratio as an NNRE divided by F par, developed by postdoc Yeru Zheng. And the beauty of this work is we don't change the two-stream approximation structure in CLM, but just implement a few semi-empirical equations in there to convert those two-stream variables estimated in CLM to the necessary variables we need to use in our algorithm. I forgot to paste the results on this high-level slide, but if you go to the iPoster that I lead, you will find validation of preliminary results showing that the simulated SIF based on our approach are more consistent with satellite SIF products than the previous approach. Next slide, please. In terms of connection to the ongoing census efforts and engagement stakeholders, we have been engaged in modeling and carbon dynamics work groups. In particular, we are connected with Dr. Roshan Kumail at Columbia and Dr. Ashbeck strategy with providing CLM simulated methane and carbon fluxes to the methane and carbon flux census efforts. We have also been keeping in touch with our collaborators from EPA and UMD and shared our progress at the GCAM annual meeting last year. Next slide, please. I don't, for the impact of COVID-19, I think there were some impacts, but not much. The biggest loss is loss of field data for our planned simulation framework work, and actually the queuing time is much longer on our supercomputers because more people are using it during the pandemic. And for future directions, particularly in this year, I think first we're planning to extend methane flux to other carbon energy fluxes within the established CLM Hector GCAM framework. I believe this can be benefited from the modeling census work that the modeling group is leading. And we are also planning to start data simulation experiments with the CLM DART framework and feed the data simulation results into the CLM Hector GCAM framework. Our postdoc, Dr. Han Chiu, has been awarded with NCAR's CIVO Wisdom Program, and we will have close collaboration with NCAR for the simulation framework. We are also continuing participating census efforts and communicating with stakeholders and publish our data and results. Next slide, please. Yep, I think that's all I have, and I think it's a lot of details in the slides, but please go to the poster if you're interested. Thank you.
Thanks a lot, Lynn. And I'm not seeing any questions for you in the chat, so if there are any questions, feel free to add them in, and we can always talk about them during the discussion afterwards. So we'll keep moving right along, and up next we have Dr. Tatiana Loboda talking about the impact of climate-driven increase in wildfire emissions on air quality and health. So go ahead and take it away.
Thank you very much, Liz. I'm going to keep my video off just to save the bandwidth here. So welcome everybody, and we're going to talk about the health outcomes of wildfire emissions, because you clearly haven't heard enough of medical terminology in the last few months, but here we are again. So just to give you a very brief overview of how this project is working in terms of framework. Nancy French and your wonderful team at the Michigan Technological Research Institute, and particularly Mike Billmeyer, are developing fairly fine resolution emission estimates using their wildfire emissions inventory system, and they're passing those emissions to us at the University of Maryland, where Don Chen and I are writing high split to distribute those emissions and calculate daily concentrations, which were then in turn passed into my colleague, Dr. Robin Hewitt at the School of Public Health at the University of Maryland, who is developing epidemiological models that actually link concentrations to specific health outcomes based on the health record with our stakeholders in Alaska CDC and Department of Public Health. Next slide, please. So we had a very productive year despite of the COVID-19 shutdowns. And what you see on this slide is the wonderful updates from the Michigan Tech crew, who have been updating their wildland fire emissions information system with Alaska-specific information and developing really nifty graphic interfaces where they're allowing users to select their area of interest to generate their emissions, giving them options in terms of different area source, et cetera, and then as you can see on the right, they're producing these awesome graphical estimates over a specific time frame using FCCS fuel bed distributions within the burned area, and also providing the emission estimates by species, both in terms of the total amount and area-adjusted micrograms per kilometer square. Next slide, please. So Mike Billmeyer generated those wonderful emissions for us between 2011 and 2019, which we loosely defined the 5 seasons to run between May 1st and September 30th. And then we take it in the University of Maryland and we run high split. For those of you who are not familiar with how high split runs, every single pixel that generates emissions is considered essentially an independent model and is tracked separately. So for this period between 2011 and 2019, we had nearly 29,000 individual models that we tracked over time and over space using high split. And the only reason we were able to do it is because we are running our processing on the HPC high-performing cluster at the University of Maryland, which is all Don Chan's really contribution, massive effort that went into making it run. But now with the simultaneous use of 135 cores, we can actually complete that run of nearly 29,000 models within 3 days. It's a tremendous improvement and allows us to run multiple estimates and learn new things a lot faster than we previously thought was going to be possible. Next slide. So the results of these models here shown, this is annual or 5-season cumulative PM2.5 concentrations between 2011 and 2019 over our domain area. You see a big range of variability, and by the way, the scale is stretched between 0 and 100. This is far from the maximum, so the red saturates at 100, but it exceeds that value quite substantially. However, if we did stretch it to the maximum, you won't see anything until 2015 whatsoever. So you see a great variability in the distribution, but you also see that in years when we've had substantial fire currents, even moderate like 2013, definitely 2015, 2017, 2019, nearly the entire state of Alaska and most certainly nearby Canada are affected by pollution from wildfire events. Next, please. In fact, when we estimate the number of days of unhealthy air quality, it doesn't seem quite so impressive within Alaska, although both Fairbanks and Anchorage are hit a little bit. You can see it in Anchorage, it's hiding behind it. But what it really shows that a lot of our pollution and the concentrations of those unhealthy days were exported to Canada and towards Mackenzie River Delta. Next slide, please. And this is the slide that shows the full stretch of those values, which actually for 2015 range between 0 and over 800 micrograms per meter square concentrations cumulative for the fire season. And the majority of impact ended up outside Alaska. Next slide, please. Here you see an animation, and it moves fairly slowly. On the left, you see our projected concentrations daily, and on the right is just surface reflectance, essentially from MODIS, that shows you the plumes and how they move through the area. And you can see that the prevailing atmospheric circulation definitely, while it sends several plumes of smoke and PM 2.5 through Fairbanks during 2015, ultimately the worst case scenarios always ended up being carried out towards Canada and Mackenzie River Delta out there. Next slide, please. So we continue working with our stakeholders, and we are preparing those PM 2.5 concentrations to transfer to Alaska CDC so that they can run the models in-house. Next slide, please. And over the next year and a half, we're going to focus on fuel map improvements. We have a really nifty scheme in place which is going to allow us for dynamic adjustments to fuel distribution and consumption. At the University of Maryland, we're going to focus a lot on understanding and into comparison between different modeling assessments, because we can produce gorgeous maps, but there's really no good way of estimating just how accurate they are. There are only 7 EPA-approved stations across Alaska as a whole, so we're bringing in citizen science through low-cost purple air observations, and we have a poster by Allison Baer that describes the relationship between purple air and EPA stations, and we're going to use those to look at a different alternative modeling approach that involves stations and AOD satellite measurements. And then our collaborator from the School of Public Health will build epidemiological models and will send them then to Alaska CDC and Department of Public Health, because usually they prefer to send models and run them where the data is housed rather than share the data out and compromise this is very highly sensitive personal information. So in general, this is my last slide. We are not greatly impacted by COVID-19. We don't have any field work, but just as I'm leaving you with the next thought, COVID-19 has been now decisively demonstrated to attach itself to PM 2.5. So areas that have high PM 2.5 concentrations also have the potential to be more infectious for COVID-19 compared to areas with cleaner air. So there's another reason to keep our air clean to the best extent possible. So thank you.
Thanks very much, Tatiana. I'm not seeing any questions in the Q&A. Yeah.
Yeah, I have a question for
Sure.
Tatiana. Just anecdotally, in my experience with closely monitoring these areas of high AFV during the Elvis campaign in 2019, we were seeing areas of high AFV as far south that originated in Alaska, as far south as the PSAT Alaskan Delta. So these potential bad air events, in addition to Old Crow and Nuvik, could affect air in Yellowknife and points south. So I wondered if you're looking at any of those impacts, or your stakeholders really are focused in Alaska.
Thank you, Peter. That's a very good question. And we are focused on Alaska simply based on where our health data are coming from. Health data are the probably greatest limiting factor. Based on what we're seeing, looking at the circumpolar and maybe even wider impacts of boreal fires in general would make a lot of sense as the next step. But at this point, we really are limited in what access to public health data we have.
Right.
So we are limited to Alaska.
Thank you.
Thanks a lot, Tatiana. Great presentation. We're going to go ahead and move on to David Lutz, who's going to talk about dynamic modeling of ecosystem processes and services in North American boreal forests. So go ahead and take it away, David. Thanks.
Great. You can hear me? Okay.
Yep, I can hear and see you.
All right, wonderful. Yeah. Hi everybody from Norwich, Vermont. It's the last day of class here at Dartmouth, so if you see some additional attendees on the list, those are actually some of my students in my science writing presentation class who are watching your presentations, and it should be pretty fun because they're also watching mine. So in class after this, they get to critique my presentation skills, so we'll see what they say. But today I'll just give some updates on our Phase 2 project, specifically thinking about boreal forest model validation using LiDAR and SIF. The PI on this project, along with Manuel Shi and Hank Shooter from UVA, Mike Powell and Frankie Sullivan from UNH, and Adriana Foster, who's a collaborator at NAU. Next slide, please. Great. So the main objectives of this project are to use a forest gap model to think about how forests change over time, basically under different types of climate scenarios and disturbance scenarios, and use that information in case studies to work with stakeholders and think about potential flows of ecosystem services. And we're going to do that by coupling the forest gap model with ecosystem service models that I've been working on. So that figure to the right there, the 4 parts really are to use remotely sensed data, many of them from the above campaign, to calibrate and validate the forest model, UVA FME, which many of you have seen, Adriana, who's working in Scout's group, and as well as Amanda, have been working on to calibrate and validate that data to get it running and adjust it in places where there isn't particularly strong forest inventory data. Take that information and bring that to stakeholder workshops where we're going to talk to them and think about particular alternative management plans that they're essentially legally bound, required to do, simulate those in the model and bring that information back to them in terms of ecosystem services, so they can kind of, not exactly in real time, but get a sense for what some of their alternative management plans might yield in terms of timber and carbon and climate services. So that's the kind of overall set of objectives for the project. Next slide, please. So the first thing, in year 1, basically, the idea is to use that remotely sensed data and think about calibrating and validating the model. So the main ways we've been doing that has been to look at T-Light overpass data from Bonanza Creek and use these LiDAR point clouds and construct vegetation profiles. And these come in the form of the vertical profile metrics and that lower image there on the left, as well as canopy surface metrics that are kind of that stream there on the right. And that's work that's been happening with Mike Tallis and Frankie Sullivan at UNH. And what we've done is started to extract sites from the phosphorite owl data set and those models, and then start to compare those profile metrics with information that comes out of UVA FME anyway, including Lori's height and the maximum height of the canopy, as well as stem counts and LAI. And those are all things we're starting to directly compare for those 10 sites. So that should line up pretty well with some work that Adriana has been thinking about with Bruce Cook and the overall geolite slice everywhere across the Tanana Valley. So next slide, please. And the second way we're starting to think about calibrating and validating the model is to use SIF data. And so this is work by Yang at UVA. And you start to take oversample triple SIF data that's been collected over Tanana Valley, and that's that shape on the left there. And you can see that these are kind of essentially what we're doing is taking out these layer stacks and converting that SIF information into TPP relationships on some of the sites. And so what we can do then is start to think about rerunning Adriana's runs in her ecological modeling paper that came out last year. And there's a TPP extension that kind of goes into that model that was used for thinking about different types of aerosols, etc. So taking that information, calibrating, and seeing how the outcomes change when you have calibrated data from SIF. Next slide, please. Peter was asking us to talk about how COVID has impacted our work, and as you can imagine, the workshops are things that you need to go slide to. I was planning on meeting with the CAC, which is the Citizens Advisory Committee, and that is a group of 12 stakeholders through the Department of Division of Forestry in Alaska who put together the management plan, essentially, for the TDSF. I had been planning to come to Fairbanks to meet with them and a handful of them and have them actually come to our Above Science Team meeting in Fairbanks, but obviously we had to reschedule that. But the cool thing that we're working on with them is they have a new data stream that gives spatial representations of stand timber sales and cuts, including future scheduled harvests. So those two maps there on the left are shape files that show where cuts happened, what was removed, and how that was regenerated, as well as you can see in that second image is a pink polygon, and that's a future scheduled harvest. So that's something that's in the process of being sold and then should be cut. And that's pretty interesting because what we can do then is think about repopulating the model at certain times and thinking about regeneration strategies for how to seed the new spot and see how things look when we model forward. I know that's something Adriana's been thinking about a lot and has some of that information. I'm not sure if it's in her poster or in a talk about the outcomes of whether you just spin the model up from bare ground or you align it to where the canopy is at the moment and then see how resilient the forests are with different climate scenarios, and that's pretty interesting. So this data stream should give us even more detail on that front. The CAC has annual meetings in May that I've attended both in last year in 2019 and then again in 2020. So we're pretty well connected with them. They're really excited about the project. Obviously, it's kind of disappointing that I couldn't get to meet with them, but we'll schedule the workshop just, I suppose, for next May. That's pretty much all we can do. If we choose to do it at other times in May, is really good because it's before a lot of the committee takes off and is busy during the summer. So next slide, please. Great. Okay, so basically the future directions, what we have in our project plan are to complete this kind of this whole case study area-wide validation and calibration with SIF information. Keep working on these model runs and comparing them with GLite, which should work pretty nicely with the domain-wide work that Adriana's doing. Something Adriana and I have talked about a lot has been on modifying this mortality subroutine, where we're going to think about integrating harvest primary inputs. And that's something that she's been working on with another project. But this is at the core of this project is adjusting the model accordingly so that we can get timber information and also adjust specifics with regards to how things are harvested. So by next May, we'll have a kind of set of simulations of their forest management plan at Kanawha Valley in prep for the workshop so that we can go talk to them, give them some preliminary maps and model output, see what their alternative management plans are looking like, and then we're going to actually be doing some pretty cool social environmental science where we're giving them sets of preferences and adding fuzzy weights to them so we can kind of see which they prefer and run that back in the model. The other last thing we're working on now is a conceptual framework manuscript where we're talking about kind of start to finish how we go from remote sensing data to ecosystem modeling and then into calculating flows of ecosystem services. That's not really particularly something that there's a nice description or kind of a nice workflow in the literature. There may be other people on the above team that would be interested in contributing to that. Obviously, we're going to think about that in the context of forest modeling. But many of you have been thinking probably about how to take remotely sensed data or modeling data and have that go into a certain type of ecosystem service platform. And that's something that we're starting to work on. And so you can just contact me if you'd like to chat about that. And the next slide, I think that's it. So this is just for me, Manuel, Hank, Adriana, Frankie, and Michael and she. If you're interested in more of this or the conceptual paper, just get in touch with me. Looking forward to collaborating with everybody, and it's just too bad that we can't all be together because I'm seeing so many people on the attendee list that I know and would just love to be talking with. So we'll just have to wait till the next time. So thanks a lot.
Thanks so much for the presentation. We did have one question come in for you, which is the calibration of the model with SIF like a data assimilation process where you would adjust the model pools?
That's a great question. I think the idea there was the initial idea for a lot of this, and probably most folks when they're thinking about integrating remotely sensed data straight into models, is to eventually have a workflow where that does update automatically. My sense was just to, and our idea is to think about the monthly SIFs and have that calibrate monthly GPP and then simulate ahead and see where it's been calibrated, where it is not, and see what the comparison is. So I don't quite think we're there to do real-time adjustments on the fly like that, but that's obviously something that I think we'd like to go to.
Great. Well, thanks very much. And we're going to move on to our next and last presentation before our discussion section. So Nancy French is joining us now, and she's going to be talking about wetland status change and seasonal inundation dynamics for assessing the vulnerability of waterfowl habitat. So go ahead. Thanks, Nancy.
Thanks, Liz. Can you hear me okay?
We can hear you, and we can see you.
Great. So I will talk today about the project that we started a year ago. My colleague...
Nancy, you got a little faint. I don't know if maybe you could put that microphone back up. We can still hear you a bit.
Can you hear me right now?
Yeah, that's good.
Okay. That was an experiment that didn't work. I want to acknowledge my co-PIs. Liza Jenkins in particular has been stepped up to help coordinate this effort. And we have collaborators at JPL, Bruce Chapman, and Ducks Unlimited, Kevin Smith and his team are really very engaged with us on this. So next slide, please. The purpose here is really straightforward to, under Objective 1, to develop some products that are useful for then Objective 2, looking at waterfowl habitat suitability assessment. This is where our Ducks Unlimited partners come into play. And so I'll go in a little bit more on the next slides on those two activities. A summary here of the remote sensing work that we're doing is using UAV-SAR for inundation and wetland type mapping, and spaceborne L-band and C-band, as well as our work with type mapping includes Landsat and Sentinel products. And so the products that we're creating are inundation extent maps and wetland type maps. But really the main outcome of the project is to demonstrate the use of these types of products and data and products for wetland dynamics and therefore waterfowl habitat. So in reality, our stakeholder engagement activity is kind of baked into it with, if you think of Ducks Unlimited as a stakeholder, having them help develop and be able to use into the future what we're developing. Next slide, please. So the wetland mapping activity follows from what you saw yesterday. Laura Borjo-Chavez, my colleague, in her phase 1 project, developed the maps that you see here of peatland types. We are extending that and have made some progress in mapping not just peatland types, but other wetland types using it's really a modified version of what's called the Enhanced Wetland Classification, a standard classification schema used in Canada. The modification is based on really how we can use remote sensing, which types are able to be of course, discerned. So on the right, you can see the classification schema that we are now going to, that's kind of enhancing this peatland map. So the area that we're working in primarily is this area that was done in the previous phase of above, and then further south into the Peace Athabascan Delta area. This is just to the south of the view you see here. This method uses a combination of Landsat and possibly Sentinel-2 data that helps discriminate upland and or wet versus dry, upland versus wetland types, and then the SAR adds in that idea of structure, vegetation structure, and wetness that provides really a fairly robust method for using random forest methodology to create the wetland map. So this is, in a way, a hybrid of work that Laura has developed from the boreal peatlands work and work that we've done in the Great Lakes Basin. That she's now mapped the entire Great Lakes Basin with a very similar methodology for wetland type. Okay, move on to the next. Thanks. And so the other product set that we're coming up with are inundation dynamics. This shows you some work that Bruce Chapman put together as an example of the UAV-SAR polarimetric decomposition that can delineate different inundation conditions. This is just an example. We have some other areas where we've been looking as well. The UAV STAR data that was collected over the Slave River Delta and other areas in the Northwest Territories will be a primary set of data that you'll be seeing in future presentations. You actually can see it on our poster. In addition to the UAV STAR assessments, we are planning, or we've looked at C-band Sentinel-1 and in order to go back in time, really, how we can use data that's in the archive to understand dynamics over seasons and within seasons. And that's been very exciting. That again also is on our poster if you'd like to look at some examples of what we've done there. So those are the two products. I think the next slide reviews the plan for, so next slide please. The next slide shows the habitat suitability modeling that is primarily being conducted by the Ducks Unlimited partners. They have data from the U.S. Fish and Wildlife Service that does duck monitoring. That's what the lines are on the lower part of this slide, showing where they've collected duck census data. And on the right-hand side, you can see the changes in survey counts. This will be compared to some of the habitat data and the dynamics, the wetland dynamics data, put into their modeling for improving their understanding of habitat suitability for waterfowl. And so I guess I can go on to the last slide, which talks about our stakeholder engagement activity. As I told you, the Ducks Unlimited folks have a little bit of, this is what they do for a living. They map wetlands, and so we're really working with them directly to improve their capability. Kevin Smith is a NASA funded in the past by our group. He learned how to use SAR back in the day when we were doing a lot of our early work in Florida. And Kevin will be working with his team, Michael Merchant in particular, to help develop the products that we just looked at and then integrate those into their capability for habitat assessment. So Ducks Unlimited, we're introducing stakeholders to both this current project and future NISAR projects. In particular, Bruce Chapman's work is integrated with the NISAR efforts to do inundation mapping globally or regionally and for areas around the world. So we plan to do periodic updates on our progress to the stakeholders, which include the Global Waters Futures program, which Jen Balzer has brought us into. She's involved. And I don't have any, I did not have the template, so I apologize. I will mention here that we do have involvement in the Vegetation Working Group and the disturbance synthesis I hope to be involved with as well. COVID-19 impacts. Well, we don't have field work for this summer because there won't be any flights, which is a problem for validation really of the inundation product in particular and for more of our wetland classification. We thankfully have a person who lives in Yellowknife who will be out making observations. They won't be able to do measurements per se, but they'll be observing inundation conditions. This is a postdoc and colleague of Jen Balzer's who's helping us. So we do have a little bit of observational knowledge that we can connect to the satellite sensing activities. Otherwise, COVID has impacted us really by not being able to employ field interns this summer, and really having to save money for next year is always difficult when we have a set of experts and salaries to cover. So having to do with cash flow in particular and how we're going to manage our budgets into the future. And of course the loss of a season of knowledge of inundation. So I think that's all I have. Is there any questions?
Thanks, Nancy. There is one question that came in for you. It is, have you explored or do you see utility in using air SWOT water elevation data sets?
So we are not directly, but we are talking with David Butman and his group, who are also working in the pad. So I anticipate that we will be integrating anything that comes out of their activity. I was also interested, so I listened to David's talk a little bit yesterday, and that was good. I also was intrigued by what Chip was coming up with related to carbon cycling in these types of places. So I think some of the work that we're developing related to inundation status, I think could be interesting to apply to some of the questions that Chip is working on. So yeah, I'm looking forward to connecting with David and Tamlin in particular on this.
Thanks,
spoiler alert, you'll hear a little bit more about the pad later on.
There we go.
PAD is the place to be, although we can't be there this year, unfortunately. So thank you very much.
Well, thanks a lot. And just as we're transitioning into the discussion time, Natalie Bowman, if you're still there, there is one question that came in for you. So I'm gonna throw it out there now, and you can answer before we start the discussion. And this was: has there been progress in the past few years on active sensing of SWE and/or snow depth?
Oh, hi. I am here, but I'm going to deflect that to John Kimball if he's here, because I think he's the better person to answer that by far. John, are you here?
Yeah, I wish I knew more than you did. There's the SNOX planning activity that's ongoing up there, but I don't think at the spatial scales that that you're targeting that there are active campaigns to actually collect those types of data yet. I think that's, last time I heard, the planning was more in the phase of something like 2021, 2022, where there's been an active airborne campaign to acquire those types of data.
In fact, the SNOX top-level science questions are specifically for improving retrievals of SWE and snow depth in the boreal forest and in the tundra. So that's their goal.
Thanks to all of our presenters, and I'm going to let Scott go ahead and take over as he moderates this discussion based on all the Phase 2 speakers. And don't forget, put your questions in the NASA Q&A platform.
And let the speakers from yesterday know that they've been promoted to the panel if they didn't notice that. So that they have microphone control.
Yeah, that's right. I think so we've all heard collectively some 20 presentations over the past 5 of them today and another 14 or 15 from yesterday. So there's a lot we could talk about, and we have had some Q&A on these. I wonder if there are more generally, for those who are panelists, questions that you might like to ask and raise at this point to any of the other Phase 2 project PIs that have presented thus far. So we'll start with that and just see if anyone who would like to unmute themselves, who has the ability to ask questions at this point. Any of the Phase 2 PIs, if you'd like to ask any questions of the other PIs. Okay, I sort of thought that might be the case, but I guess more generally, I wonder about for all of those of you who are all now sort of phase 2 PIs, if you have any thoughts or feedback in terms of, your engagement of above sort of coming into a suite of projects from phase 1 are already well along. And if you have any thoughts or comments or even questions about what that process has been like. And if, for example, you found it easy to participate in working group activities or not.
So, Scott, I'll jump in here. It's Nancy first. Can you hear me?
Yep.
Okay. I just wanted to mention, because I that I do think that there's a decent amount of attention to the question of wetlands and wetland dynamics, carbon, and all of the variety of things happening in soils and wetlands related to carbon cycling processes, other than just, for example, methane. I think that one of the ways we might move forward is for us to have a discussion that may build into some kind of a more core group of people to collaborate on some of those questions where we've had fairly good working groups related to upland vegetation types, but I think the wetlands have had less, congealed groups of people. So it's where I think I would like to just have some conversations with others, Chip and Tamlin and others that are working on this type of thing. I'd be interested in talking with you guys.
So Nancy, this is a great idea. We can ask Josh for the official number, but my understanding is that even the permafrost adapted land surface models typically only have one plant functional type or wetlands. And while the number of the species diversity is relatively small, as we saw from Phil Townsend yesterday, the functional diversity is still quite high. And so I expect we would see that within the distribution of plant functional types as well.
Yeah, that sounds great. I would be very interested in that, and so keep me posted. I'd be happy to move things forward a little bit, because really with NASA's capability that Laura Borger-Chavez has developed, SAR can tell the difference between different types of wetlands, which is, very, very impactful, and we should take advantage of that, along with the SWOT water level capability, and that so far those haven't been tied together, and then of course the work you're doing, Chip. So I think it would be great to just have a small working group maybe to start with to talk about what we might do together.
Working group on wetlands.
I think that's what we call it, unless we have one already that's kind of close. And I think when we have has more to do with soil moisture and soil water dynamics, if I'm not wrong.
This is there's a subgroup synthesis activity that's dealing more with surface water connectivity that Tamlin and John Mettler are leading. And I'll talk a little bit more about that Wednesday. So there's some overlap with that.
Well, that might be where I integrate into looking more at this more spatially discrete dynamics of ponds and wetlands. So I'll look into that. Thanks, John.
Yeah, the working group you were thinking of, Nancy, is the radar, soil moisture, and wetlands working group. So it's kind of specific to field data collection during the radar set and the UAV SAR and air mass overpasses. So yeah, you would need a different one or be part of John's.
Sounds like it's a hybrid between the two.
Yeah. Well, maybe it's a crossover between the two. So I wanted to mention that. I just wanted to mention that we do have a lot of field data we've archived on the DAC, especially for some of the new projects they might not know. So we were out in the field mostly when the STAR was flying over, but we have a lot of data and photos and everything on the vegetation. So I was thinking about that when Phil was talking. I don't know if it's useful to him, and we don't have the type of data that he was collecting, but we do have some information that maybe might be useful for that project and some of the others that were presenting yesterday.
Yeah, that's great. Thank you, Nancy. Laura.
It's okay.
But I also
Hey, this is Chip. I was really intrigued to hear the number and variability in the SIP talks that we heard. So we've got Fred looking at things. We've got Christian and his group looking at things. We've got the two different CLM groups looking at stuff. And we haven't heard from Howie yet, but I know that he's been looking at productivity across the Arctic as well in his functionality, and Amanda's been working on that. So I wondered if there had been any discussion between these groups about how to join forces and fuse data.
I think we'll probably hear a little bit more about that in the synthesis report tomorrow afternoon, or Holly is on the agenda to talk about some of that. So I don't want to shut off this discussion, which is good, but we're 5 minutes over, but there is also a question that has come in from the platform, which I'd like to ask of those phase 2 PIs who presented, and that is, what is the overlap between the various stakeholder groups the different PIs are working with, and could there be more collaboration between and among them? If anybody wants to speak to that.
So the only thing I can say is within the people working within Northwest Territories, we've done a fairly good job of talking with each other. So I think we have a good feeling for that overlap, although, again, I haven't talked to David or Tamlin very much specifically about stakeholders. But I think, in a way, it's almost a regional thing or a sub-regional thing that happens because of the way stakeholders land that way, but that's just my point of view.
I would add to Northwest Territories that agree with Nancy and say that we've had a couple of stakeholder engagement workshops in Yellowknife that have reached a large number of people within GNWC and some of the First Nations and some of the land management agencies that used to be federal and now are territorial. That's kind of a comment for the 139 participants who might not be aware of that. So I know you are, and I'm looking at you there. And of course, we had planned a wonderful stakeholder engagement spearheaded by Alison York in Fairbanks. And maybe one of the things that we can talk about tomorrow in the recovery strategy would be what we should aspire to do between now and when we might be able to meet in Fairbanks in 2021.
Yeah, I think that's a great idea, actually, and it's a great question that somebody raised. I'm not sure who, but clearly there are a range of stakeholders that many of our projects are working with, from Park Service and Fish and Wildlife and on the Canadian side as well as the Alaska side. So, and probably, I know there are some collaborators, there are managers who are probably on a couple different projects, but there's probably also a lot of room to engage others from those various agencies or to have a discussion with the various groups for who among these different agencies is part of their projects, and are they even aware of each other, being involved in these different projects. So I think that could be a really interesting conversation when we get to meet again and have a breakout session, which is something that's rather difficult to do in these virtual meetings. So thank you for the questions and the feedback, and I think we probably should move along and hear from Chip now on the status of the airborne campaign for next year.
Great, thank you very much. So there's a lot of material here, and a lot of it is intended for you to go off and read on your own afterwards, but I wanted to try and chronicle where we are with the airborne campaign. There's been a great deal of work done, not only by individual groups looking at the different sensors, but we're now moving towards multi-sensor syntheses, as you'll see from these and you've seen from the previous talks already. So let's see, next slide. I think we can just skip through a whole bunch. Yeah, next. Keep going, keep going. There's the overview paper. Okay, so here we had flights in 2017, 2018, 2019. The big addition in 2019 is we got Elvis back to pick up a lot of data that was not able to be acquired in 2017. And unfortunately, we've had to postpone the 2020 campaign into 2021. And there was a question earlier on about SNOX and a potential above cold season component. And because of government shutdowns and COVID and other things, we just haven't been able to get that all aligned. But there's been extensive discussion with the program managers at NASA headquarters, and in principle, everyone is aligned and supportive of this. But we just need to get the resources and the teams lined up to be able to do this. So stay tuned for update on that. Next, please. Okay, skip that one. That's for reference. And next are pictures, so you can see people having fun during the 2019 campaign. Next, please. Continue. And there's some Elvis pictures. So the Elvis 2019 campaign, which took place before the G5. I have to say that the G5 is an awesome platform for the type of work that we need to do in the above domain. It's got incredible range and endurance, and we were able to make real-time, in-the-air decisions based on conditions that we encountered in different parts of the domain, and divert to other parts of the domain and just pick up lines that we had already planned in. So that was a tremendous asset for this. Continue, please. So just to give you a comparison, we had some technical issues in 2017 with the aircraft, and that hindered the amount of lines that we were able to acquire and the distribution of them. You can see the map on the left-hand side showing the 27. So a number of the tracks that you can see from Elvis acquisitions here are lined up and underfly ISAT-2 and JEDI, and I know that people are already starting to take advantage of this. Next, please. This is the data quality map, and so the green lines show you the good acquisitions, greater than 50% of surface returns. The yellow are the kind of marginal, and yellow and orange are marginal, and the red are basically where we didn't get anything useful at all. And so, next please. You can then go to NSID. Oops, sorry. And so there was a wonderful set of opportunities as we were flying in and out of Fairbanks to pick up transects over the Shovel Creek fire. And so there's a number of good lines covering through there, both inside and outside the burn area. And so that should be some excellent data for our people studying disturbance to use as well. Next, please. And this shows you the link where you can find the data at NSIDC. So I encourage you to go there. Although Liz tells me and reminded me to tell everyone here that for the ease of use for above PIs and researchers, all of the airborne data sets are being ported over to the above cloud once they've been published to the DAX. So you can manipulate these data within the above cloud using your tools that are set up there and not have to worry about going out and exploring the data at the DAX and pulling them all together. Next, please. So we've had 3 years of excellent Avarice acquisitions. Here's the map showing where all of the individual lines are, and we've covered about 30,000 square kilometers per year, maybe a little bit more in some of the years, and so we're nearing 100,000 square kilometers of acquisitions. If you think about that, from a 5-kilometer flight altitude, we get a 5-meter pixel resolution, so that's 25 square meters. And in some areas, we've been rastering back and forth and making maps of several thousand square kilometers. And so from 25 square meters to 2,500 square kilometers is 8 orders of magnitude. And we get complete coverage in those areas. And so this is really going to be powerful as we begin to address scaling issues across spatial scales. And people can use the individual pixels or aggregate them together, and this is going to be, I think, one of the ways that we're able to really transform our understanding from site level to landscape and even regional scales. Next, please. So what I've done is to break these down into a number of little focus studies. You heard from Phil Townsend yesterday about some of his work, and even saw a bit from Charles. Here's the Canadian High Arctic Research Station up in Cambridge Bay. Next, please. And you get a picture of Donald and Eric, and then Eric hiding down in the grass with Phil. Next, please. They were out collecting the ground truth data while Avarice was flying overhead. So on the left-hand side in white, you can see the Reiner watershed. You can see highlighted in yellow 2 of the sub-watersheds that are focus areas, and the plan for Avarice to fly and collect all the data. On the right-hand side, you see the actual as-flown lines. Next, please. You can get some imagery from what things look like. So this is the RGB composite from Fabian Schroeder and Phil. Next, please. You see the SWIR composite, or sorry, NIR composite. And next, you'll see the minimum noise fraction, which shows that there's actually a tremendous amount of information here. And as I mentioned earlier, while there's limited species diversity or limited taxonomic diversity, we fully expect to find quite impressive functional diversity, and we'll be exploiting that. So even in a place like Chars, which is truly Arctic, we're seeing quite a bit of diversity. Next. And I think this is going to be, so mapping with what Donald and his team have done with their meter scale ecosystem classification, we'll now be able to link together the functional and taxonomic and investigate those in detail. There's also UAS acquisitions, which will be complementary here, and that's a theme that runs throughout many of the areas that we've been probing. Next, please. Okay, so Herschel Island, where Islandmeyer, Smith, and team has been working. This is also one of the Cabo areas. We were able to make 2 acquisitions here in July of 2019. Next, please. And so Isla and her team were on the ground. You can see on the left-hand side the composite for the 2nd of July and the composite for the 27th of July. Quite possibly 2 of the only cloud-free days that they had during their entire stay there during the summer. Jim Kirby's done some nice work on this in putting things together preliminary. You can see the evolution of the vegetation over just the 1 month here. And next we get the LR versions, so you can see on the next slide, yeah, there we go. You can see what it looks like in long wave red, and you can see how things are changing as well. And as I mentioned, this is another place where we get not only ground truth, but UAS data at centimeter scale resolution, so we'll be comparing against that as well. Next. We can skip actually about 5 charts since I spoke about these things yesterday. So 2, 3, go through. This is all the methane work at Big Trail Lake. Next, please. Fluxes, next one. So people can go back over those. I just wanted to highlight that one of our focus areas is Utqiagvik, which many of us still think of as Barrow. And we've got several different above projects working here, as well as collaborations with NG Arctic and NEON. Next, you can see in the composite that we're able to map out not only this whole area, which includes all of the NEON box and the NG Arctic sites, but a number of sites where above investigators have been working hard for many years, and we've got the ability to link this into some extended time series. And Fred, it'll be great to see how you are able to continue to use the Avarice data. I have a note here that we've got awesome data from 2017, 18, and 19. It typically occurs in early July, and I know there's been a push from the team to look at the possibility of getting something nearer to max greenness, which is usually 1 to 15 August. That's been balanced in the past against priorities of trying to get to some of the Canadian high latitude sites, which typically open up for investigation in the early August timeframe. So perhaps in 2020 we can flip things around and try and get a later acquisition over Barrow area. Next, please. Sorry, 2021. All right, so here's the promised pad focus. Largest inland delta in the world, and it's a critical boreal wetland. Next, please. Here's a picture. I believe that if you look down in the lower center, you can see David Buttman and Catherine Kuhn taking the photograph, and they were giving us real-time updates. If you look closely, you can see up in the upper portion how wonderful and pristine the clear sky conditions are. But if you look down at the horizon, you can see a layer of wildfire smoke. And that really inhibited our operations and our ability to collect good data. And we were dancing around the smoke depending on which way the wind blew, literally. Next. So here's the planned acquisitions over the pad, linked up to cover the entire area that had been sampled on the water by the Buttman and Smith groups and Pavelski as well. On the right-hand side, you can see the real acquisitions. We flew on the 16th, and one of these jumping over to avoid the smoke and try and get some clear skies. Next, please. Okay, so here's the lay of the points that were sampled in 2018 and then mostly again in 2019. And then you'll get an overlay. Next chart, please. So here are the actual acquisitions from the 16th of July. We actually targeted the pad 3 different times during the week of 15 to 20 July while the water team, I won't say the land or ground team, were out there. And this is the best day of acquisition that we had. Next, please. You'll see also that there were air SWAT water elevation acquisitions in 2017. Nancy mentioned this. And next, I had the 2018 overlay of the L-band SAR data. So this is becoming a nice synthesis area, and when we add in the work that Nancy and her team are doing, I think we've got a lot of excellent opportunity to really crush this area and use it as a high-profile synthesis for above. Finally, next one, please. There's been some work already published. You'll see a summary, the highlight for Ethan's paper, where the air SWAT data were used, and in the middle you can see the L-band data and its ability to tease out information on inundation, not only where the water is, but where the water has been recently, shows up nicely in the L-band data. Next, please. So moving on, we have the Seward Peninsula, where we're working a lot with the NG Arctic team. In yellow, you'll see outlined here the Council watershed near Council, Alaska. High detailed information on the ground and from UAS from NG Arctic. Next, please. You'll see some of the retrievals that have been done for the Avarice data here, showing albedo, showing just the reflectances, and then also showing neat nitrogen content. Next. And Daryl Yang has a nice eye poster that covers all of this and some more detailed retrievals and the fusion of that with the UAS data that have been acquired. We're also using Council, Teller, and Krugerrach in the Seward Peninsula as test beds to test out some remote sensing theory where we can go from centimeter scale spatial resolution in the UAS data to meter scale resolution with the SAR and Avarice data to hundreds of meter scale with Sentinel, Landsat, and MODIS. And so we're investigating how the spatial scaling of the remote sensing asset impacts the actual retrievals and the uncertainties for various remote sensing variables that people are interested in. And we're then using that to understand how our vision of the Pan-Arctic might be altered by consideration of the spatial scale of the remote sensing assets. Next, please. Okay. Cole gave a nice talk on Arctic Cap, so we can go through these pretty quickly. You've seen the vertical profiles. Next. There we go. So here are the vertical profiles by month, all aggregated. Next chart shows you a comparison of two sets of vertical profile of the vertical profiles in the Mackenzie Delta area for 2017, July 10, and next, this should be August 30th, so you can see how things are changing over time. And next, you'll see some results from Abhishek, where we've been now comparing the model data against the airborne data, and additionally there's some really nice work on looking not only in the above domain, but across the Pan-Arctic at what we're seeing. And so taking these things into account, we've got some nice modeling work that Abhishek is leading. Next, please. Finally, I want to just do some L-band SAR update. Next. So here are a whole bunch of charts. Here's a screenshot from the Burns area from August of 2019. Next, please. And you'll see that it actually overlaps nicely the Old Black Spruce site that Christian spoke about yesterday, as well as the Jack Pine site. And we've got these data for several years. Next, please. Kevin Schaefer's been doing a lot of great work on looking at soil moisture and active layer thickness inside and outside of burns. And so here are some results from his team looking at the Yukon Delta area. This is also where Sumas Halley has flux chambers and a flux tower set up. And so we're keen to understand the correlations between what we're seeing in these physical variables with what we're seeing in the carbon fluxes and dynamics. Next, please. Nancy mentioned the mapping at the apex site. On the left-hand side, you'll see 3 successive photographs across the growing season, and in the middle, you'll see the images that she's already shown. This analysis is led by Bruce Chapman, and we're understanding now how we can begin to use not only snapshots, but begin to look at seasonal changes in inundation in some of these dynamic ecosystems. Next, please. I think John spoke about this yesterday. We've got permafrost active layer modeling using both L-band and P-band SAR. There's a paper by Richard Shannon, its highlight, going over that. Next, please. And here's from GO, looking at what's happening on some of the permafrost and active layer thickness dynamics in the Yadoma Hills inside of the Anaktuvuk River fire scar burn up on the north slope. Next, please. And then Yonghong Yi has been doing some interesting modeling looking at the zero curtain. I believe John mentioned this also. On the right-hand side, you can see estimated 2007 zero curtain period duration for the north slope, and how just in the 8-year period from 2007 to 2015, how the zero curtain duration has extended. And we believe that this is something that our radar technologies are able to get at, and would love to be able to do some late season flying to really demonstrate this with both L and P-band. Next, please. I believe that's the completion of the things that I wanted to say. So if there are any questions, I'd be glad to entertain those or defer to the next discussion section.
Chip, there's one question. If the airborne presentation will be available off of the agenda, I think that you had to check on some results with folks on that, right?
Yeah, I just wanted to make sure that the things I've included, everybody who has provided those, thank you, by the way, to all of the investigators who have provided information for these various airborne briefings that I've been giving. I just want to check to make sure that everybody's comfortable with what's included there, and once that has been confirmed, we'll edit as necessary and then post it.
There's also a comment here that AVRIS-NG has been converted to Northup GeoTIFF and is in the analysis ready directory on the Web Science Cloud.
Yeah, so let me just speak to that for a moment, Peter. The AVRIS team, because they deal in relatively large data volumes, pack data in a way that is most efficient and doesn't always go with true north up. And I know a lot of people like that, so Mark Carroll and his group have very generously created a set of north up GeoTIFFs that are available on the above cloud. Thank you to all of you who have been looking really hard at the AVRIS data and letting us know about other deficiencies. The data did have some geolocation issues. There were some offsets that were identified, and an older processing script has been replaced, and the data has been reprocessed. And I believe that all of them have now been queued up and are ready to go to Oak Ridge to update the data that are there. So if you haven't looked for the new geolocated data from AVRIS, please do so. And again, explore the ELDIS data at NSIDC DAC, and the L-band and P-band, the L-band SAR data are at ASF at the SAR DAC there.
Hey, Chip, this is Hank. Can you explain at all that minimum noise fraction that you were showing with the AVRIS? I think
if Bill is still available, he would be the person better to do that, but it's basically just an indication of information content.
Yeah, that's really what it is. It's two sets of principal components analysis, one to remove the noise, and then a second one on the noise weighting data. And you think of like a scree plot to identify the amount of information content that's in the data. David Thompson had a paper on this a few years ago. And then in terms of that particular image that Chip showed, it's just showing sort of a hand-selected set of bands to illustrate the information content. It's really hard to show people visually how much information is in imaging spectroscopy data, and so that's one way of just trying to give a visualization that this is not the same as standard multispectral data.
Yeah, so when David was talking yesterday and mentioned that Catherine had done a nice survey of the above domain with Landsat looking at changes in watercolor, I had sent her a note saying that, there's a wonderful opportunity here to compare the changes in greenness that one can get from the Landsat data with the very rich spectral information that AVIRIS contains. And so there's probably some target areas that one could investigate and exploit there.
All right. Well, I want to start wrapping up here. I want to say thanks to everybody for all their talks today and the discussion that we've actually managed to squeeze in there. And we're still going to try to return again starting up at 3:30 Eastern Time. So try to come back on the WebEx at 3:25 to give us time to make it on there. And I want to say just thanks again, and we will see all of you this afternoon. All right.